Hello everyone, welcome to the JEE Mains exam that was conducted on 22nd January 2025. So let us start with the first question. The first question was actually based on the instrument. The statement question was given, and I think in this particular session there were 2-3 questions that was based on statement. So the first statement question is, in a vernier caliper, one vernier scale division is always smaller than one main scale division. Isn't that true? Vernier scale divisions are smaller than main scale division, right? So the answer, I don't have to explain anything much over here. It is right. The Vernier constant is given by one main scale division multiplied by number of vernier scale division. Well, that is wrong. That is wrong. Vernier constant. There are two definitions. One is one main scale division minus one vernier scale division. And one more definition we can give is one main scale division divided by one vernier scale division. Number of vernier scale division. One main scale division divided by number of vernier scale division. This would actually give us the answer. Clear? So, this statement is wrong. Vernier constant is also called as least count. It is also called as least count. Clear? So, the answer is statement 1 is true but 2 is false. Moving on to the next question. A line charge of length a by 2 is kept at the center of the edge BC of a cube. Having edge A, if the density of the line is lambda c, that is lambda coulomb per unit length, then the total electric flux through all the faces of the cube will be. What is the question? Total flux through all the faces of the cube is. See, if a cube is given and you can see the charge over here, laid over here, the size is, the cube has a side of A and the length of that line charge is A by 2. So, let us ask the question, how much charge is contained in it? Charge contained in it, charge is equal to lambda multiplied by the length. Charge per unit length multiplied with length will give you the charge, and that charge is lambda A by 2. But if you notice something, if you have a wire at the edge of a cube, that edge is shared by 4. If you imagine 4 such cubes around it, one here in front, then one at the bottom, one at the other end. Now I can actually draw the cube for you. You can see this is the cube and the charge is sitting right here having a size of A by 2, and that space has been shared with, you can imagine, 4 cubes next to it. We can imagine that being enclosed by 4 cubes. There you go. Now look, we have the charge, that is lambda A by 2, being shared among 4 cubes. Now you can see it is completely inside. If I ask you the question, what is the total flux? What is the total flux equal to? The charge that is sitting inside, charge inside divided by epsilon naught. And what is the charge inside? Lambda A by 2 divided by epsilon naught. This is the total flux. Okay, and don't you think symmetric, this charge is actually sitting symmetric over there? If it is sitting symmetric and the total flux is this, what is the flux through one cube? One cube through one cube, the flux is equal to lambda A by 2 epsilon naught is already there. So, you get see it is going to be 1 by 4 lambda A by 2 epsilon naught, which is equal to lambda A by 8 epsilon naught. Clear? Lambda A by 8 epsilon naught would be our answer. Moving on. 28. 0.8 volt is given. You can see resistor Rp, which is 1 ohm. This is the resistance of the entire line. And then there is another wire that is connected over there, 2 ohm. Sliding contact of a potentiometer is in the middle of the potentiometer wire having resistance Rp, 1 ohm as shown in the figure. And external resistance Re is equal to 2 ohm is connected via the sliding contact. What's the answer? What are they asking? They're asking, they haven't, okay, I guess they forgot the question. They framed the question, they forgot the question. The question is, we have to find what is the current flowing in the circuit, and I guess they haven't been specific or anything. We will just find the main current flowing in the circuit, which is quite ambiguous. They should have put the question. I hope there is no question that has been edited over here. Again, redraw the diagram. We have a cell of 9 volt cell, and you can see that the potentiometer wire having Rp 1 ohm as shown in the figure, and external resistance 2 ohm is connected via the sliding contact. And sliding contact of the potentiometer is in the middle of the potentiometer wire. So the sliding contact is in the middle. That means the entire wire can be divided into 2 parts. Okay, I will divide into 2 parts for convenience. This is half ohm and this is also half ohm. And the sliding contact is going to be exactly the center, so which means it is dividing the resistance wire into 2 parts. This is equal to 2 ohm. Okay, all right. If this is a case, what is the main current in the ammeter reading is what they are asking actually. So this is something that I had to guess actually. 2.5, you can see they are connected in parallel, so we can write R effective over here would be 2 into half divided by 2 plus half. It is always better to work with fractions. So 4, 5, 2 by 5. Clear? So R effective in the first case 2 by 5. That is connected in series with half. So R in total will be equal to 2 by 5 plus 1 by 2. What is the answer? 4. 4 plus 1, 5. 5 by 10, which is 1 by 2 again. Let's confirm 2 by 5, 4, 5. Oh, I guess this is 2 to the 4. 4 plus 5 divided by 10, that is 9 by 10, my bad. 0.9 ohm, that's the resistance, clear? Effective resistance of the entire circuit is 0.9 ohm. So what is the current? Current in the circuit is equal to the total potential difference divided by the effective resistance. So what is the effective resistance? Well, I is equal to voltage is 0.9 divided by 0.9. So the answer is 1 ampere. So 1 ampere, option 3. All right. Moving on. Again, assertion reasoning question. Assertion A. If Young's double slit experiment is performed in an optically denser medium than air, clear? If it is transferred from air to the denser medium, then the consecutive fringes come closer. They are asking that whether the fringes, will it come closer or not? We know the fringe width beta is equal to fringe width, the distance between 2 fringes is beta, and that is equal to lambda d by d. Clear? This is the story in air. Now, if it is in a medium, then we will be having lambda d by refractive index into d. So, you can see beta in the medium is beta in the air divided by the refractive index. So, what is happening? You can see the lambda changes to lambda by mu. Clear? Wavelength is changing over here. So, let us look at it. Is the first statement correct? You can see if beta mu is greater, so you can see that this is greater than 1. So, that ensures that the medium will be having lesser fringe width when compared to the air. So, beta, the fringe width is actually lesser, comes closer. That is correct statement. Clear? Assertion is correct. Let's look at the second reason. The speed of the light reduces in an optically denser medium than air while its frequency does not change. What happens with the speed of light? Obviously, when the light travels from rarer medium to denser medium, speed of the light decreases. V decreases. V is directly proportional to wavelength, and then we can see if V decreases, lambda will also decrease. If lambda decreases, then we can see that the statement is actually the reason. Speed of the light decreases, so that is definitely right. Reason is also the correct answer. You can see wavelength decreases because again wavelength is inversely, you can see that how the wavelength changes. Wavelength changes, you can see how the wavelength is changing. So it explains everything. Clear? It's because of the light speed decreasing when it travels from rarer medium to denser medium. That is the whole reason why the fringes actually come closer. So it is also the correct reason. So the answer is going to be option 1. Moving on. Two spherical bodies of same material having radii 0.2 meter and 0.8 meter are placed in the same atmosphere. So that means the surrounding temperature for both of them are same. Surrounding temperature is same. Okay, temperature of the smaller body is 800, bigger body is 400. If the energy radiate from the smaller body is E, and the energy radiated from the bigger body is, assume the effect of the surrounding to be negligible. Okay, so we are ignoring the outside temperature. So how does, here comes the question, they are asking if the energy radiated from the smaller body is E. Energy radiated. If an object has something called temperature, if the energy is radiating from it, coming out from it, then how do you write that expression? dq by dt is equal to E sigma A T to the power 4. This is a formula. Clear? You can see how it depends on the temperature and the material. Nature of the material also matters. You can see that since they have been specifically asking about the rate of change of temperature, rate at which the energy is radiated, I have to use dq by dt itself. So I have to confirm this. So dq by dt is proportional to area. That means 4 pi r square, surface area is what they are considering. So r square into t to the power 4. So what is the energy radiated in the second case? Let's say it is E dash. In the first case, it is E. So what is the radius in the second case? You can see that we can write r dash square divided by r square into t dash to the power 4 t to the power 4. R dash by r, you can see that r dash by r is equal to 0.8 divided by 0.2, which is equal to 4. And similarly, t dash divided by t is equal to, you can see it is T dash, the temperature of second body is 400 and the first body is 800. So that is 1 by 2. Let's substitute it. So you will get 4 square into 1 by 2 whole to the power 4. So we get 4 into 4 into 1 by 4 into 4. So what do we get? We see E dash must be equal to E. That's it. Clear? Energy radiated will be exactly the same. Moving on. Amount of ice. An amount of ice of mass 10 to the power 3, 1000 kilogram and temperature minus 10 is transformed to vapor of temperature 110 degree by applying heat. The total amount of work required for this conversion is. Alright, I usually prefer to convert into calories and then solve the problem, and I think I can do the same thing over here also. So for that you need to remember the expression of specific heat capacity in terms of calorie per gram. So this is going to be, specific heat of ice is going to be 0.5, specific heat of water is equal to 1, specific heat of water vapor is equal to 0.47, if I am not wrong, it is 0.47, and specific heat or latent heat of fusion is equal to 80, latent heat of vaporization is equal to 540. Clear? Units are there, definitely. All right, these are the things that you need to remember. Now see, what are we doing? Now from minus 10 degrees Celsius, minus 10 degrees Celsius, we come down to 0 degrees Celsius, and then we are converting into, so from ice we convert into water, and then water at 0 degrees Celsius, and then water's temperature rises to 100 degrees Celsius, correct? And then from 100 degrees Celsius you are converting into steam. So that also it is getting converted into steam at 100 degrees Celsius, and then the steam's temperature is increased by 10 degrees Celsius. Clear? So this is the whole process. So we had to find the energy in all of these cases. All right, amount of ice given is 10 to the power, I guess it is minus 3. 10 to the power minus 3 kg. That means 1 gram it is. Clear? 1 gram. So let us write it. Specific, what is the energy required? Q is equal to, in order to convert the minus 10 degrees Celsius ice to 0 degrees Celsius ice, Q is equal to 1 into 0.5 into change in temperature, which is 10, plus. Now you are converting its state from ice to water. So that is going to be 1 gram into 80. Clear? Latent heat is given, plus once again 1 gram. So you are now converting it from 0 to 100 degrees Celsius. So that is going to be, specific heat is 1 and the change in temperature is 100, plus. And then we are getting it converted to another state, that is steam. So for that required energy is very high, that will be 540, and then plus. Next is 0.4, okay, all right, the mass is 1 gram. So 1 into 0.47 into change in temperature is 10, and we are done. So this is going to be 5 plus 80 plus 100 plus 540 plus 4.7. Annoying part is 4.7. Okay, so let us add for 640, 720, 725, 729.7. So close to 730. And if, okay, see with 730, I want to convert this is in joule, I'm sorry, this is in calorie. I have to convert the calorie into joule. So that's how it is given. So 730 into 4.2. Now let us multiply it. 73 into 42. I borrowed the 10 over here. 6 and is a 14. 4 3 are 12. 7 28, 29, 6 6 0 3 0 6 6. Answer that is closer. Oh, I can see only one answer that is closer to it. That is 3043 joule. Clear? That would be the answer. Okay. Moving on. An electron in the ground state of a hydrogen atom has an orbital radius of 5.3 10 to the power minus 11 meter. In the ground state, radius is 5.3. or 0.53 10 to the power minus 10 Armstrong, while that of the electron in the third excited state is 8.48 into 10 to the power minus 10. So, okay, electron's energy in the third excited state is 8.48, all right. The ratio of the de Broglie wavelength of the electron in the ground state to that in the excited state is, all right. We know radius is directly proportional to n square into r naught. This is how you write it. And for velocity, we can write it, L is equal to nh by 2 pi, which is equal to mvr. We know this formula. And from this, we can find it for the velocity. So, vr is directly proportional to n. R is directly proportional to n square. So, that means V is inversely proportional to n. All right. And they are asking what is the ratio of de Broglie wavelength. lambda is equal to h divided by mv. So, lambda is inversely proportional to v, which now I can say that the ratio de Broglie wavelength of the electron. So, de Broglie wavelength of the electron in the ground state to that of the de Broglie wavelength in the excited state is equal to speed of the wave in the excited. Okay, but we know one thing, that speed is inversely proportional to n. That means this is going to be directly proportional to n. So, that means n in the excited state divided by n in the ground state. And what is the value of n in the excited state? In the excited state, since they said it is the third excited state, if they say it is a third excited state, then n will correspond to 4. N equal to 1 corresponds to the ground state. Clear? Anything above that, say second would be the first excited state, 3 would be the second excited state, 4 would be the third excited state. So, the answer is equal to 4 divided by 1. So, the answer is option 1. Clear? Moving on. In the diagram given below, there are 3 lenses. Comparing negligible thickness of each them as considering negligible thickness, each of okay, so we have to imagine it is having negligible thickness in all the cases. Radius of curvatures of both the surfaces are given. The first surface is given having a radius of curvature R1. Second surface is given radius of curvature R2. Radius of curvature of both the glass lenses are given. The power of the combination is, we had to find the power of the combination. So, how many combinations are there? You see a water that is forming a plano-convex lens, then again a lens over here, and at the bottom we have a plano-concave lens. Clear? Plano-concave lens. So, you can see obvious lens over here, and the top one and the bottom will also form the lens. So, what is the answer? So, effective power is equal to P1 plus P2 plus P3. So, P1, what is the power in the first case? Now, we know focal length is equal to R by n minus 1. Okay, if it is a plano-convex lens, please remember the formula F equal to R by n minus 1. Okay, so if I rewrite it, I want power, so 1 by F, it will be n minus 1 divided by R. And since it is a plano-convex, I can write it just R1, n minus 1 divided by R1. Okay. They haven't given what the radius of curvatures are, so I have no idea about whether it is a concave or convex or convex or concave lens. Clear? So, I am just calling it just a lens. So, how do you write for the second one, power in the second one? And by the way, this is the refractive index of water minus 1 by R1, which I guess we can obviously substitute the values. 4 by 3 minus 1, that will be 1 by 3, 1 by 3 R1. Power 2, that will be equal to refractive index of the glass minus 1 into 1 by R1 minus 1 by R2. This is a general formula. So, power 2 is equal to refractive index of the glass is 3 by 2 minus 1 into 1 by R1. You see, if you consider this as the lens, light is coming like this. Imagine the light is coming like this. And you can see if the light is coming like this, every measurement is made from this point. And you can see the center of the first curved surface is going to lie over here. So, we are going to measure it from here this way, opposite to the light ray. So, that is why we will put minus 1 by R1. And for the second surface also, you can see the center is going to lie on this side. Again, we are going to make our measurement from this point to the center, and that is again a negative. So, minus of minus plus 1 by R2, and the power of the second would be 1 by 2 minus 1 by R1 plus 1 by R2. That is also done. Next, power 3 P3 is equal to what is the concavo-convex lens, and that is again concavo-convex. If you are dealing with a concavo-convex, plano-concave lens, plano-concave lens, then the expression is minus R by n minus 1. If it is a plano-convex, r by n minus 1. Plano-concave, it is going to be minus r by n minus 1. If it is a equiconvex, r by 2 into n minus 1. Same thing over here, equiconcave, minus r by 2 into n minus 1. So, there is definitely a minus there. So, a reciprocal of that would be 4 by 3 minus 1 with a minus sign outside divided by r2. What do we get here? We get 1 by 3 minus 1 by 3 r2. So, what are the formulas that we have? P1, P2, P3, P effective. What is the P effective? P effective is equal to 1 by 3 R1 plus 1 by 2. Okay, I think I can open the bracket here. I can definitely write minus 1 by 2 R1 plus 1 by 2 R2, and then I will write this function minus 1 by 3 R2. And we can see that things are together, R1 and R2 are together. So, here if you conclude it, you will end up with minus R1, okay, the R1 is common, we can take it outside. So, other than that, 1 by R1 into 2 minus 3, that will be minus 1 by 3, oh, minus 1 by 6, minus 1 by 6, that is the first part. Second, you can see R2 we can take it outside and you will get 3 minus 2, that is plus 1 by 6, plus 1 by 6. Now, let us get it all together, that is equal to 1 by 6 into 1 by R2, 1 by R2 minus 1 by R1. This is what we are getting, 1 by 6 into 1 by R2 minus 1 by R1. Let us check. We don't have an answer. Maybe we have. We'll take minus outside. So, minus 1 by 6 into 1 by R1 minus 1 by R2. Option 2. Clear? Option 2 would be the answer. Here I would suggest that, the main confusion that you can have over here is about the sign convention. Please be very careful, there are certain equations that I do rely on, where I can use the formula, without much thinking. So, here you can see that, when it comes to a plano-convex lens or equiconvex lens, I can definitely say the sign convention is plus over there, r by n minus 1. If it is a concave, if you see it's a concave written over there, so minus r by n minus 1. Here, with the second lens, we do have a confusion there, but you can see then we have to use the sign convention the way I have shown over here. This would actually help you solve the problem very easily. Clear? Okay. That was actually, that particular question was a little bit, smart way of framing the question, so that the students are, it is trying to check the understanding of the ray optics, what kind of how to use the sign convention, etc. All right, moving on. An electron is made to enter symmetrically between two parallel and equally but opposite charged metal plates. So, we have two plates here. Two plates, each of 10 centimeter. So, 0.1 meter there. The electron emerges out of the field region with a horizontal component of velocity 10 to the power 6. So, electrons is entering and it comes out with a horizontal speed of 10 to the power 6 meter per second. If the magnitude of the electric field between the plate is 9.1, so that means the electric field over here, let's say it is 9.1 volt per centimeter. Please be very careful about the sign, the units that they have used. Electric field is 9.1 volt per centimeter, something that's big deal. 9.1 into 10 to the power 2 volt per meter. The vertical component of the velocity of the electron is vertical component of the, okay, this is the component that we need. And you can see, if you think about the question, you'll notice that if the electron is traveling like this and if there is a field, electric field in the downward direction, definitely the charged particle is going to bend. Clear? The charged particle is going to travel like this and then it will have two components, horizontal and vertical. The horizontal component they have already given us 10 to the power 6. We have to find what is the vertical component. How do you do it? Well, okay. There is a constant electric field in the downward direction. Because of the electric field, the charged particle is speeding up, accelerating. What is the acceleration of the charged particle? Well, the acceleration of the charged particle is equal to QE divided by m. Let us find this first. They have given it's an electron, so 1.6 10 to the power minus 19. And what is the electric field over here? 9.1 10 to the power 2 and divided by the mass, which is 9.1 into 10 to the power minus 31. 9.1, 9.1 gets cancelled. So, what is the acceleration? Acceleration is 1.6 into 10 to the power minus 19, 10 to the power minus 31. Well, that is going to be 12. 10 to the power 12 and that is 14, 10 to the power 14. Let's confirm this again. Yes. Acceleration is, oh, that's quite large. 10 to the power 1.6, 10 to the power 14. Okay. All right, okay, I guess that's a very big number. Okay. So, that's the acceleration. And you can see the electron, okay, if it is accelerating, what is the velocity that it gains? Velocity that it gains, you can see initially there was zero velocity along the y-axis. In the downward direction, there is absolutely zero velocity. There is nothing, no velocity in the downward direction. Later, it gains a velocity v. So, that means the initial velocity is 0. So, we can write Vy equal to Uy plus Ay into t. This is the acceleration along the y-axis, downward direction. And now we can say Vy is equal to, this is 0, Ay is 1.6 into 10 to the power 14 multiplied by time taken. What is the time taken? See, the time is, you can see the electron is coming out of the metal plate. So, it is covering a distance of what? 10 centimeter, which is 0.1 meter. Clear? How you can see that the velocity in the horizontal direction, that is 10 to the power 6, does not get affected because there is absolutely no acceleration in that way. So, the time taken to go from here to here, we can easily calculate. Time is equal to distance divided by speed. So, that means time is equal to 10 to the power minus 7. Clear? 10 to the power minus 6, there is a 10 to the power minus 1, so 10 to the power 7. So, into 10 to the power minus 7. So, what is the velocity in the y direction? 1.6 into 10 to the power 7. Let's check. We don't have, it is written in meter per second. We have 1.6 10 to the power 7, which we can write 16 into 10 to the power 6. So, we do have option 3 as the answer. All right, moving on. Which of the following resistivity versus temperature curves is most suitable to be used in wire bound standard resistor? I would say that, please make sure that you read the NCERT, note down all these tiny details. They have elaborately given about the graphs. Make sure you study them. And what is the answer? Well, usually you can see if it's a normal conductor, you can see that it is going to be like this. You can see resistivity changes very rapidly with temperature. But what do we prefer? We actually prefer, alloys. Alloys actually slows down. This with the increase in temperature, resistivity does not increase much. So, that graph is going to be option 1. You can see as the temperature increases, resistivity does increase. There is no question about it. It is increasing, but it is increasing very less. Clear? Least actually. And if you check the NCERT, they would have given you the markings over here also. It will be like 100, 200. I think just 200, 400, 600. That's how they gave it. For this one, you would see that the temperature range is like from here to here. It is 100. You can see it's very quickly rising. Here, very slowly for wire bound resistors. This is for semiconductor, and this I have no idea. Maybe semiconductor gone wrong. All right. So that's option 1. A closed organ and an open organ pipe tube filled by two different gases having same bulk modulus. Watch out for that. Same bulk modulus, but different densities rho 1 and rho 2. Frequency of the 9th harmonic of the closed pipe is equal to 4th harmonic of open pipe. They said 9th harmonic equal to the 4th harmonic of open pipe. If it is a closed pipe, how do you write the frequency? Frequency for the closed pipe is given by, if they say 9th harmonic, closed pipe can only have odd harmonics and 9 is the odd over there. So, 9 V by 4L. Clear? I know you will be using the formulas like 2n plus 1, etc. over there, but they are asking for the 9th harmonic. Clear? I usually prefer it like this. Fc is equal to n dash V by 4L, where n dash are odd numbers. Clear? N dash is a odd number. So, 9V by 4L, 9th harmonic. Directly they have given this. Length is L1, 9V1, and what is that matching with? 4th harmonic of V2 divided by 4L2. Not 4. Oh, it's a open. So, it is 2L2. Okay. This is going to be 2, and that we get 9 by 8 equal to V2 by V1 and also L1 by L2. Now, let us check this out. Length, I guess, that's what they want. The length of the open tube is what they want. They want L2. So, I can write L2 is equal to L1 into V2 by V1 into 8 by 9. First simplify it and then we will substitute the remaining. V2 by V1. What did they say? V is equal to root of gamma P by rho. This is how you write, isn't it? Speed of the sound wave. But remember, what is this gamma P? Gamma P is the bulk modulus. And they said two different gases having same bulk modulus. That means speed is only dependent on the density. So, we can say V2 by V1 is equal to root of rho 1 by rho 2. Rho 1 by rho 2 is 1 by 16 and that is 1 by 4. So, we can directly substitute it. So, L2 is equal to L1. What is L1? L1 is 10 centimeter. They want the answer in centimeter. So, 10, we will keep it 10. V2 by V1 is 1 by 4, 8 by 9, 4 2s are. So, you get 20 by 9 centimeter. 20 by 9 centimeter. Moving on. All right, moving on. A uniform circular disk of radius r and mass m is rotating about an axis perpendicular to its plane, passing through its center. A small circular part of radius r by 2 is removed from the original disk as shown. Moment of inertia of the remaining part of the original disk about the axis is. See, whenever such a question is given, they already have a disk having a certain moment of inertia, and from that disk a small portion has been removed. How do you find the moment of inertia? So, this is how it is going to be. And if you notice how they removed the disk, this is the portion remaining. We have to find the moment of inertia. So, how do we do this? A part of radius r by 2 is removed. Okay. Entire radius is r. This is r by 2. What is the moment of inertia about an axis passing right through the center? First, you find the moment of inertia of the complete disk without any hole in it. Complete disk. If it was complete, what is the moment of inertia? Clear? A uniform disk of mass m and radius r rotating is passing through its center. A small circular disk of r by 2 is removed from the original disk. So, the initial mass was m. Clear? Without anything removed, initial mass was m. And for that, you have to find the moment of inertia. Then subtract the moment of inertia of the smaller disk. Find out what is the moment of inertia of the smaller disk about this axis and subtract it over there. That's the idea. So what is the moment of inertia of the complete disk? Moment of inertia of the complete disk is, it's a disk. So axis passing through the center perpendicular to its plane, mr square divided by 2. This is R. And now you need to know what is the moment of inertia of that removed portion over here. What remains same? It's a uniform disk, uniform circular disk. That means the mass density or the area density is going to be the same. That means mass per unit area is same. Okay, if the mass is m, the complete mass, area would be pi r square. If the mass of this disk, if I call it as m dash, area of that is going to be pi r square by 4. So what do we get from this? M dash is m by 4. Check it out. Okay, obviously this 4 is the only factor over there, it has to be divided, m by 4. So you should not spend much time over there. What is the moment of inertia of that tiny disk, small disk? This is a complete disk. Oh, that is equal to, you have to use the parallel axis theorem, because see, for the smaller disk, axis passes right through its edge. Clear? It is passing right through its edge. So what is the moment of inertia? That is going to be m by 4. And remember, don't forget about the radius of the disk. It is r by 2, not r. Clear? So m by 4, r by 2 the whole square divided by 2. This is mr square by 2. Plus the separation between, this is an axis passing right through the center of mass, that's been written over here. I hope you do know the parallel axis theorem. So plus mass is m by 4 again into the separation between the parallel axis, that is r by 2 the whole square. So that is equal to, this is 4, 4, 4, 16, 32. So mr square by 32 minus mr square by 16. What is this answer going to be? But not minus, plus. I was wondering why am I getting a moment of inertia negative. Anyway, now I think it's clear. So 3 by 32 mr square. That's the moment of inertia of the smaller disk. What is the remaining moment of inertia? Remaining moment of inertia is going to be the earlier value, mr square by 2 minus 3 by 32 mr square. What is the final answer? That is 16 over here. 16 minus 3 is 13 by 32 mr square. Option 4. All right. A small point of mass m is placed at a distance of 2r from the center O of a big uniform solid sphere of mass m and radius r. Gravitational force on m due to capital M is F1. Then afterwards, what happened? A spherical part of radius r by 3 is removed from the big sphere as shown in the figure. Gravitational force of m due to the remaining portion is F2. Find the value of F1 and F2. Well, this is how it is. From the big sphere, a small sphere had been removed. They have already given that the mass is at, this is m. It is already sitting at a distance of 2r from the center. So that means this is r and this is also r. And this distance is r by 3. So the distance of this tiny sphere, from the point M, this distance we need is r plus r by 3, which is 4r by 3. Let us find what is the gravitational force, because the entire sphere without any hole in it is F is equal to gm m divided by 2r the whole square, which is 1 by 4 gmm by r square. Okay, this is F1. Now the second part, let us do one thing. Again, this is similar to the question that we have done earlier, the moment of inertia case. How did we find it? If I want to know what is the gravitational field on the gravitational force on M because of the sphere from which a small part has been removed, first find what is the gravitational force created by the entire sphere at this on this mass M. Then find the gravitational force created by the tiny sphere on M. then subtract both of them. That will give you the answer. Clear? So this is how I am going to do it. One I have already found. We have to just find the gravitational force because of the tiny mass. Volume, I mean, you can see that volume density is constant in both the cases. So I can say mass by volume is equal to m dash by 4 by 3 pi r cube by 27. So m dash is equal to m upon 27. Clear? All right. So what is the F because of the smaller sphere? That will be equal to G m by 27, m divided by radius is, okay, the distance of separation is 4r by 3, that will be 16r square by 9. And then we can rewrite this as Gmm by r square into 9 by 16 into 27. 9 3s are, there you go, Gmm by 48 r square. Let me just confirm this one. We are finding the force because of this one. So the radius is, the distance is 4r by 3, 16r square by 9. Mass is m by 27. We have considered that. Well, this is the answer. And now let us find F2. F2 will be Gmm by 4r square minus Gmm by 48r square. And what is this going to be? 48 would mean 12. 12 4s are. So 12 minus 1, 11 Gmm by 48r square. Okay. So the next is the ratio that we need to find. If I take F1 is to F2, let's write F1 by F2. F1 by F2, we will get 1 by 4 here, and here it will be 11 by 48. 48 goes upstairs, it will become 12 by 11. That will be our answer, option 3, 12 by 11. All right, then I hope you can see that it's a little lengthy, not much. Just have to be very careful with the masses that we take, the distance that we take. That's it. Okay, moving on. Work function of cesium and lithium metal are 1.9 and so on. So incident light of wavelength 550 nanometer on these two metal surface, a photoelectric effect is possible in the case of. So we just have to figure out how much energy is stored in the 550 Newton. That is going to be 12400 divided by 5. Okay, I will convert the nanometer into Armstrong. That will be 5500. E is equal to, okay, this is 55. You can see that is going to be 2 times 55 2s are, so 1 2 4 55, that will be 2 times, that will get 110 there, and then you have 1 4 4, and I guess once again you have to go 2 times only. So 2.2 something is what I am getting, 2.2 electron volt something is what I am getting. So that means the work function is 2.2 electron volt. Oh, sorry, the incident light is 2.2 electron volt. So definitely it will remove the electron from 1.9 electron volt. Clear, work function is less. So, and 2.5 is too much. So it will not be able to sufficiently able to remove the electron. So definitely the answer is going to be cesium only. Okay, moving on. It's a very simple question. Magnetic field is given B, permeability of free space is mu naught, dimension of B by mu naught. Think about a formula that is connecting them. B, we can say B is equal to mu naught by 4 pi I dl sine theta divided by r square. I hope you do remember this formula. That's it. So B divided by mu naught is what we want. 4 pi is a constant. Clear, we don't have to consider that. Sine theta we can remove. So what we remain with is I dl by r square. Current is ampere, length is meter, meter square. So the answer is ampere per meter. So ampere per meter. So L minus 1. L minus 1. This is the answer. Option 2. A very straightforward question. Clear? Nothing magical over here. Alright. A bob of mass m is suspended from point O by a light string of length L and left to perform vertical motion, a circular motion. So vertical circular motion. Initially, by applying horizontal velocity v0 at the point A, the string becomes a slack when the bob reaches at a point D. So that means the tension at this point is equal to 0. That means the velocity, this actually gives us a hint that it should have been projected with a minimum velocity. And what is the minimum velocity for a string case? Root of phi g r. Yeah, root of phi g r, and at point A. Okay. The ratio of the kinetic energy of the points at B and C, what is the answer? See, if at this point, if it is root phi g r, at the top it is going to be root g r. And at this point, at an angle 60 degree over here, it will be root 2 g r. And at this angle 60 degree, it will be root of 3 g r. Root 4 g r. And the middle over here, it will be root 3 g r. And they are asking us about these two. Well, how do we get these velocity? How do we find this velocity? In a vertical circular motion, if you remember, the velocity v is equal to root of u square minus 2g r into 1 minus cos theta, where theta is the angle measured with the vertical. What I mean is, this angle, if the particle is at point A, angle that it makes with the vertical is 0. When the particle reaches the point B, I'll show you how to find the one case. So at point B, you can see velocity at point B, you can see it is equal to root of u square. We know what the answer is, phi g r, which we already know, minus 2 g r into 1 minus cos 60. What is cos 60? Half. 1 minus half is half. That gets cancelled, and the answer is root of 4 g r. I hope you understood. Clear? These values, if you can remember, it will be just great. And the ratio of the kinetic energy of the bob at B and C is, so kinetic energy at point B and C, if you find, that is going to be half m is there, and we are going to square the velocity. It is going to be at B and C. So 4 g r divided by half m, 2 g r. So the answer is 2. All right, moving on. The equivalent EMF of two non-ideal batteries connected in parallel is smaller than either of the two EMFs. The equivalent EMF of two non-ideal batteries. Non-ideal batteries would mean there are internal resistors linked with it. So E effective. How do you write the effective? E effective is equal to E1R1 plus E1R2 plus E2R1 divided by R1 plus R2. This is how the E effective is written. Okay, and they are saying that if the EMF, the equivalent EMF that you are going to get will be actually smaller than the EMFs of both of them. Smaller than the smallest is what they are saying. What is the answer? We can do one thing. We can check this. E effective, we can put random numbers, let's say, let's call this as 1 and 2. Let's call this is 1 and this is 2, and let's say this is 4 and this is 5. And let's check this out. So you'll get 1 into 4, 4, 5 2s are 10 divided by 9. And that is equal to 14 divided by 9. And you can check what is the answer that we're getting. It's really 1 point something. Definitely not smaller than the smallest. Clear? Not smaller than the smallest. You can try with different numbers and you will see that the EMF does not, equivalent of two EMF. See, in one case itself, the random case that I took, one case itself, it is giving us the answer between 1 and 2 volt, which means that statement itself is wrong. Clear? This doesn't work every time. So, equivalent internal resistance of two non-ideal batteries connected in parallel is smaller than, okay, equivalent internal resistance, yes, of course, internal resistance, how do you write it? R1 R2 by R1 plus R2. You can check this, you will see that the equivalent effective resistance is smaller than the smaller of them. Okay, so this statement is, say statement 2 is correct, statement 1 is wrong. So we can say 1 is false and the statement 2 is correct. Okay, so here we have a case, which of the following circuits represents a forward bias? Forward bias means this end of the diode, if you have a diode like this end should be higher potential, this end should be lower potential, that's it. Now look, minus 10 and 0, who is higher? 0 is higher, this is lower. Wrong, correct, lower, higher, doesn't work. Minus 10, minus 15, who is lower here? More negative is lower, lower potential, higher potential. Is this forward bias? Yes, it is. Next, higher, lower, correct, higher, lower. So this is again forward biased. Lower and higher, okay, let's check again. Lower potential and this is the higher potential. So you can see this is forward bias. No, it's not forward bias, because I hope you understood that. This is lower potential here. And next one is 0 volt over here and 2 volt. So 2 volt means higher potential here, lower potential here, forward bias. So this is correct. So how many of them are forward bias? The answer is A, B, C and E. B, C and E. That is option 3. That is the correct answer for that particular question. A parallel plate capacitor of capacitance 40 microfarad is connected to a 100 volt supply. Now the intermediate space between the plate is filled with a dielectric material of dielectric constant K equal to 2. Due to introduction of the dielectric material, the extra charge and the change in the electrostatic energy in the capacitor are. Okay, they said that the capacitor of 40 microfarad has been already connected to a 100 volt battery. So what is the energy stored in? U is equal to half CV square. So 40 micro into V square, 100 square, that is equal to 20. So 20 into 10 to the power minus 6 into 10 to the power 4. So 20 into 10 to the power minus 2, 0.2. Use 0.2 joule. Yeah, 0.2 joule. That is the initial energy. Next, what is happening? Now the space is filled with a dielectric over there. Clear? Now you are putting a dielectric in between the space. So what is going to happen? When the dielectric is introduced, obviously the capacitance is going to change. Clear? What are they asking? They are asking the extra charge and change in electrostatic energy. Let us check out, what is happening to electrostatic energy. They did not tell anything about removing the battery. Since they said what is the extra charge is going to come inside only if, you can see that extra charge is not 0. So extra charge is going to come only if there is a battery connected over there. Clear? Battery connected. If there is no battery connected, there won't be an extra charge over there. So, okay, what is the initial charge? Q is equal to CV. So that is 40 into 10 to the power minus 6 into 100. So that is equal to 4 millicoulomb. After introducing the dielectric, capacitance increases K times. V does not change. So K is 2. That means the energy becomes 8 microcoulomb. I hope you understood. C will become Kc. V will remain same. So Q dash is equal to 2 times this value, 8 millicoulomb. So what is the charge entering? 4 millicoulomb. Clear? The extra charge. But what about the energy? U2 is equal to half. Capacitance becomes Kc. Voltage will remain the same. Kcv square. And that means we have already found half Cv square. So K is 2 into 0.2. So it is 0.4 joule. There you go. The answer is going to be extra charge is 4 millicoulomb, and they are asking what is the change in electrostatic energy. What is the change here? Delta U is equal to 0.2 joule. Just be very careful. This is the answer. Okay, moving on. Given is a thin convex lens of glass, each side having radius of curvature r. One side is polished for complete reflection. At what distance from the lens an object be placed on the optic axis so that the image gets formed on object itself? So, if you take a lens and silver it, if you take a lens and if you silver it, what will happen? It will behave like a mirror. Clear? It will behave like a mirror. So, if that is the case, refractive index is equal to mu, and you know that the light that is entering will enter through the lens twice, hit the mirror once and then come out. Clear? This is the journey. So, if this behaves like a lens, if this behaves like a mirror, and if the image and the object should be at the same place, that means we are looking at the object distance that is equal to 2f or r. Clear? So, we just have to find the f effective. So, we will start with the power of the lens. P effective is equal to power of each one. So, power of the lens plus power of the mirror plus power of the lens. So, you can see it is 2 times power of the lens plus power of the mirror. How do you find the power of the lens of an equiconvex lens? Power of the lens is equal to 2 into n minus 1 divided by r, which I have already mentioned. For equiconvex lens, this is how the power is written. Okay. So, 2 into 2 times refractive index is mu minus 1 divided by r plus power of the mirror. It is a converging mirror. You can see concave mirror, right? It is concave, it is converging. So, power is going to be positive. Power is going to be positive, and power is going to be written as 2 by r. So, it is plus 2 divided by r. So, what are we getting? 4 mu by r minus 4 by r plus 2 by r. We get 4 mu minus 2 divided by r, which we can write 2 into mu, 2 mu minus 1 divided by r. And that is the power. And focal length is going to be r by 2 into 2 mu minus 1. But what is object distance? It is 2 times f, right? 2 times f would mean it is going 2f would mean r by 2 mu minus 1. That is the answer, r by 2 mu minus 1. Clear? That is it. Moving on. Two soap bubbles of radius 2 centimeter and 4 centimeter are in contact with each other. The radius of curvature of the common surfaces. If there are 2 bubbles given to you, where do you think the pressure is going to be the highest? Small bubble or the big bubble? The answer is excess pressure. You can see the bubbles will be having excess pressure. Excess pressure is inversely proportional to radius, which means the smaller one will be having higher pressure. So, that means he is going to push more. So, the common surface is more going to look like this, and they are asking what is the radius of this part, and the radius of that one is given by r is equal to r1 r2 by r2 minus r1. I am saying this is r1 and this is r2. Clear? So, that is the common radius, and what is that equal to? And by the way, this is a simple calculation. You know, here let us say the pressure is P1, here the pressure is P2. So, the P effective is written as P1 minus P2. P effective, you know, it is equal to 4, since it is a bubble, it is 4T divided by R is equal to 4T by R1 minus 4T by R2. 4T gets cancelled, and there you go, that is the answer. So, what do we get over here? 4 into 2 divided by 4 minus 2, 8 by 2, that is 4. There you go, that is the answer. Moving on. They are asked in centimeter, I am glad. that we don't have any confusion there. Clear? The driver sitting inside a parked car is watching vehicles approaching from behind with the help of his side view mirror, which is convex mirror with a radius of curvature 2 meter. Another car approaches him from behind with a uniform speed. The car is coming towards him with a uniform speed of 90 km per hour. That means it is going to be 25 meter per second. And they have said the radius of curvature is 2, so focal length is equal to plus 1 meter. Because it is a convex mirror, plus 1. When the car is at a distance of 24 meter, that means object distance is given, u is equal to minus 24 meter. Obviously, you know, this is how it is. We have a convex mirror and the car that we are talking about is approaching in this direction. Clear? Stop judging the car. The magnitude of the acceleration of the image of the side view mirror is A. Okay, what is 100 A is the question. So, I hope you understood. So, every measurement is made from this spot, and when we measure, you can see the position is going to be 24. You are going to measure this way. So, it is going to be object distance is equal to minus 24. Okay. So, I will move this out. Okay. So, mirror formula we know. V is equal to UF by, I will just find the position of the image here. V is equal to UF by U minus F, and what is that equal to? Minus 24 into 1 by minus 24 minus 1 minus 24, well, that is going to be plus 24 by 25. V is equal to 24 by 25. Okay, let's just confirm once again, V equal to UF by U minus F. We are talking about the mirror. So, mirror formula is 1 by F is equal to 1 by V plus 1 by U. And we will definitely get this equation, and minus 24 into 1 minus 24 minus 1. That's right actually, plus 24 by 25. That's the image distance that we are getting. All right. They are asking what is the magnitude of the acceleration of the image. What do? We will write the formula. We will do one thing, we will differentiate this formula. What do we get? We get 0 is equal to minus 1 by V square dV minus 1 by U square du by dt. Clear? I am just differentiating it, just normal differentiation. Minus 1 by V square dV by dt minus 1 by U square du by dt. Easy to say, right? Minus 1 by V square, this is velocity of the image, minus 1 by U square, velocity of the object. Okay, now I am going to differentiate this again because I am not looking for velocities, I am looking for the acceleration, right? So, before I do that, I know the velocity of the object. I know it's 25. Velocity of the object is 25. I will check out what is the velocity of the image. Velocity of the image I get is equal to minus V by U the whole square into VO. And what is that? Minus V by U. What is V? 24 by 25. U is minus 24. The whole square into 25. And what is this? 24 gets cancelled. So, you get 1 by 25 square minus 1 by 25. This is velocity of the image minus 1 by 25. Okay. Image distance is 24 by 25. Object distance minus 24. All right. Next one. Differentiate this. You will get. See, you had to use the product rule, UV rule over here. When you differentiate this, you will get minus again, so minus of minus plus 1 by V cube, and you will get dV by dt. That is velocity of the image again. So, image square plus not plus, minus again, because we are going to differentiate this one. So, we will keep 1 by V square alone. Differentiating that, you will get AI. That is what we want, AI. Minus of minus, again, we will get plus 1 by u square d by dt, that is v naught square, minus 1 by u square AO. And we know acceleration of the object is actually 0. It's moving at a constant velocity. So, one thing is gone. And all I have to do next is just rearrange it. So, I get this one, I will put it on the other side. So, AI by V square is equal to VI square by V cube plus VO square by U square. Well, that's the equation that we have got. That is not the final expression, sure. And we can do as AI is equal to, put V square on the other side, V square gets cancelled. So, here you will get V, and VI we can, okay, VI I know what it is. So, VI square divided by V plus V naught square into V square. But there is something that I have missed out over here. There is 2 here. When you differentiate, there you will get a 2 here and a 2 here. Oh boy, 2 here and a 2 here. Well, 2Vi square, and here we get 2Vo square. Same here, same here. 2Vo square, Vo square, there is V square, and then you have U square. Okay. That's V by U the whole square. Okay, so AI is equal to, now we can substitute it, 2 into, what is velocity of the image here? 1 minus 1 by 25 the whole square. So, 1 by 25 square divided by image position. What is the image position? That is 24 by 25. So, here we get 24 by 25, one of the 25 gets cancelled, plus I do feel that there is something missing again. This is U cube, not this one. Here U square, this is U cube. Yeah, this is U cube. And this is U cube. So, 2 into V naught square. What is V naught square? Object V naught square with object velocity, that is 25 square. So, that is 25 square into position of the image, 24 by 25. So, 24 square by 25 square divided by U cube, which is minus 24 cube. 20 for this we can cancel here, this will go, and what we get is 2 into 24 by 25 plus, not plus anymore, it is minus, not 24 by 25, it is 2 divided, oh boy, 2 divided by 24 into 25 minus 2 by 24, done. And then we get 2 into 1 by 25 and 24 into 25, we can multiply with 25 over here. So, you get 2 minus, we can multiply with 25 here. So, 25, that is 50 here, divided by 24 into 25. We get 48, 48 here, 24, 48, that is 2 times, and 4, you get 4 by 25. And we are, this is the AI, and we are looking for 100 A, clear? A means the AI is what they are looking for. So, 4 into 25 into 100, that will be 4 times. Oh, I think I have already considered this is 2 extra, and you get 2 by 25. 2 by 25 here, this is also 2 by 25, and then you end up with the answer 8. That is the answer, clear? 8 is the answer. 3 conductions of conductors of same length having thermal conductivity so and so is given 100, 0, theta. This is what I guess, and that's what we need to find. Area of cross section of the first and second conductors are given same. Third conductor is double. This is AA and we can write it as 2A. That's what I have written. And conductivity is double than of the first. Temperatures are given. Steady state condition. What is the value of theta? Done. How do we solve this? Well, we can write it like, we can find the equivalent of K1 and K2. You can see they are connected in parallel. Clear? These two are connected in parallel. I'm going to replace this with one resistor, one heat resistor. Okay. So it is going to be like this. 1 by R effective is equal to 1 by R1 plus 1 by R2. And we all know what resistance, heat resistance would be in L by Ka. So R effective, I will write R effective is equal to L divided by K effective into 2A, because I am going to replace these two with 1. Clear? So the area collectively is A plus A. Length remains the same for both of them. So this is going to be K effective 2A divided by L, which is equal to K1A by L plus K2A by L. And L gets cancelled, A gets cancelled. So what is the K effective equal to? K effective is equal to K1 plus K2 divided by 2. This is the K effective. Okay, this is the K effective. All right. So now look at this. Now we have two resistors, heat resistors. Clear? One is K3 and the other is K effective that we have seen, K1 plus K2 by 2. The in-between temperature is theta. Here it is 100 and here it is 0. We know one thing, that the heat, it is a steady state they have mentioned. So that means heat traveling over here and heat traveling over here must be exactly the same. So what is the K? How do you write the heat transferred over here? We can say Q by T is equal to K effective, K1 plus K2 divided by 2. K effective, Ka divided by L. So A is 2A divided by the length over here. What is the length? The length is L. And that into the difference in temperature. You can see that difference in temperature is 100 minus theta. And that must be equal to K3 into 2A divided by L into theta minus 0. Now you can see 2A, L, 2A gets cancelled, K1 plus K2 by 2. What is K1 plus K2 by 2? K1 plus K2 by 2, that will be 60, 180, 90 here. 90 into 100 minus theta is equal to K135 into theta. Okay, we can 90 and 135. I think we can go with 9 ones are 9, 10, 9 ones are 9 fives are 15. There you go. 5 twos are 5 threes are. So you get 200 minus 2 theta is equal to 3 theta, which is 5 theta is equal to 200. Theta is equal to 5 fours 20. So 40 degrees Celsius. That is our answer. Clear? The answer is going to be 40 degrees Celsius. Okay. All right. And you can see that I have simplified this circuit, because I know that if I simplify it and replace with one rod, then the amount of heat entering over here and amount of heat leaving over here will be exactly the same. And then I can equate it and then I can find the in-between temperature. Clear? All right. Make sure that you practice more questions on this. Again, these are like bunch of data that they have given, and we have to substitute this over here. They're increasing our work over here. That's it, nothing else. So RA, let us write all these values first, So alpha 1, so 1 T square I cap plus alpha 2 over here is 3N T J cap plus alpha 3 is 2 T K cap. And they have also spoken about the velocity. So I will do one thing, I will differentiate this and keep. So 2 T I cap plus 3 N J cap plus 2 K cap. Done? Velocity is done. RB is equal to, again we will differentiate it. What do we get here? Beta 1, okay, alright, what is beta? Would be RB equal to beta 1 is minus 1. So, minus T I cap. Beta 2 is, oh, beta 1 is 2. Beta 1 is 2 T I cap. Then minus T square J cap plus 4P T K cap. And differentiating this, VB equal to 2I cap minus 2TJ cap plus 4P K cap. Alright, these are the velocities, etc. And you can see at T equal to 1, velocity of A and velocity of B, magnitude wise, they are same. So, we let it substitute it velocity of 1. So, what do you get? VA magnitude is equal to VB magnitude at T equal to 1. So, what do we get? We get root of, the magnitude is what they are asking. So, it will be 2 square plus 3n the whole square plus 2 square is equal to root of 4 square plus 4t, oh no, not t, 4 square plus 4p the whole square, and take the square root on both the sides, and you will get the answer here. Why am I squaring it again? It is already squared. So, this must be 2 square and 2 square. 2 square and 2 square, and then square on both the sides, you will get 2 square, and you can see that certain terms are going to get cancelled. 2 square, you can see this will get cancelled. So, we end up with 3n the whole square equal to 4p the whole square, which is 3n is equal to plus or minus 4p. This is what we are getting. 3n is equal to plus or minus 4p. It can be plus or minus because again you are taking square root on both the sides. So, you can end up with a plus or minus 1, minus p. Okay, all right. So, next condition they have given is the velocity. They are orthogonal. Orthogonal means the velocities are perpendicular to each other. So, that means we have to take dot product and they should be equal to 0. So, if I take the dot product over here, what do I get? VA vector dot VB vector is equal to 0 implies VA VB, and that too happening at the same 1 second itself. Okay, so that means this is going to be 1, 2 to the 4, then 3n minus, okay, 3n minus 6n, minus 6n. Then there is 2, 4, 8 plus 8p, and that is equal to 0. All right. We can write it as 2 minus 3n plus 4p is equal to 0. And definitely if I put np, so there are two possibilities here. 3n could have been 4p or 3n could have been minus 4p. If I put 3n equal to 4p, you can see it, no, I am not getting any answer. So, among this would be wrong and this would be the correct. Clear? 3n equal to minus 4p. Now, you put over here minus 4p over here, this will become plus 4p is equal to 0, and they get 8p, 2. So, p is equal to minus 1 by 4. And similarly, if I put the p once again over here, 4 minus p equal to minus 1 by 4 minus 1. So, I get 2 minus 3n plus, that will be minus 1 again, minus 1 is equal to 0, and I will get 1 equal to 3n, n is equal to 1 by 3. So, n equals 1 by 3, p equal to minus 1 by 4. So, we got the values of both of them. And now, let us go for the question, this is a little stretched, like little longer. And what are we getting? The next question is, we had to find what is the magnitude of angular momentum of particle A with respect to position of the particle B. Okay, let's be very careful over here, very careful. Magnitude of angular momentum of particle A with respect to the position of particle B. Angular momentum of particle A with respect to position of particle B. They did not say angular momentum of A with respect to B. They said angular momentum of A we had to find with respect to the position of the particle B. As seen from B, if you are standing on B and looking at it, what is the angular momentum? Well, that equation is going to be RAB, L is equal to R cross B, right? Momentum, whose momentum are we finding? Magnitude of angular momentum of particle A. So, this is going to be momentum of particle A. And the other, we had to find the position, clear? The position, separation between A and B. That's what this is. So, what is the separation between? So, RAB is equal to, okay, all right. Let us be a little careful here. So, is it RAB or RBA? So, we are okay, position of the particle A with respect to B is what we want. So, I hope you understood this is going to be RAB is what I have written is correct. RAB is equal to RA minus RB. And what is RA and RB? And we have to find again at 1 second. So, RA 1 I cap plus 3 j cap, no, n is equal to 1 by 3. So, we have to substitute that over there. N equal to 1 by 3, that will be 1 again. So, I cap plus j cap plus 2 k cap. I cap plus j cap plus 2 k cap minus VB, no sorry, RB 2 I cap minus j cap, 2 I cap minus j cap. This is minus 1 by 4, correct, minus 1 by 4. So, it is minus k cap. So, 2 I cap minus j cap minus k cap. 2 I cap minus j cap minus k cap. And when you subtract it, you get minus I cap, j cap plus 2 j cap plus 3 k cap. This is what we are getting. And all we need to do is angular momentum of A, we can find the magnitude I j k minus 1, 2, 3, and the momentum of particle A, we can write it as the magnitude of what is the mass of the particle, 1 kilogram, and velocity of particle A is 2 plus 1, 2 I cap plus j cap plus 2 k cap. 2 I cap plus 3 j cap, no, velocity is going to be 2, 1, 2. Let me check again. 2, n is 1 by 3, so you will get 1 here. This is 2, 2, 1, 2. That's what we got here. I cap into 2 to the 4 minus 3 minus j into minus 2 minus 6 plus k cap into minus 1 minus 4, and this is going to be I cap plus 8 j cap minus 5 k cap. And that is the angular momentum. What is the magnitude of the angular momentum? That is root of 1 plus 8 square plus 5 square. And that is equal to root of 1 plus 64 plus 25, and that is root 90. And they are asking what is inside the root, and that is 90. That will be our answer. Yes, I do understand that the last two questions were actually a little longer. Correct. You have to be very careful, what they have meant over there with respect to position of the particle B. Clear? That is a tricky one. Okay. A particle is projected at an angle 30 degree from the horizontal at a speed of 60 meter per second. The height traversed by the particle in the first second is h0 and height traversed in the last second before it reaches the maximum height is h1, ratio of h0 by h1. See, a particle has been projected and reaches the maximum height. Let us find, you can see angle is given, speed is given, you can find what is the time of flight, what is the time taken to reach the maximum height, not time of flight, half of it. So, I will write u sin theta by g. U is 60 into sin 30 is half divided by 10, you get the answer as 3. Clear? Time taken is 3 seconds. Okay, so time taken over here is 3 seconds. So, after 1 second it will be somewhere here, and they are saying that the height reached at that moment is h0. This is h0, and then it further goes. This is time is equal to 1 second, this is time equal to 3 seconds. So, 2 seconds it should be somewhere here. So, that means this must be the last second. This is what they are calling h1. So, the last second before it reaches the maximum height. So, 2 second to 3 second time interval 1 second, there you go, h1. Alright, well, how do you find h0? See, this is all y, clear, the y at a particular time. So, y we know for a projectile motion is u sin theta t minus half g t square. U, what is the initial velocity? 60 into half, because sin 30, half. 1 second minus, this is 5 into 1 second, this is 30, 30 minus 5, that is 25. So, first height is 25, this is h0. Next, I will find what is this height, okay, let us call it as h, okay, simply as h. We will find what is that. So, y is equal to, again I am going to use the same idea, 60 into half into 2 here minus 5 into 2 square. So, you get 30, 60, 60 minus 5 4s are 20. So, you get the height as 40 meter, clear. And what is the maximum height? Well, that formula is h is equal to u square sin square theta by 2g. U square is 60 into 60 into 1 by 2 into 1 by 2 divided by 20. 3, 30, 15, 45. 45 meter. So, what is this h1? So, the complete height is 45 meter. This height will be this 45 minus h, which is equal to 40. You will get the height as 5. And if I take the ratio of h0 by h1, h0 is equal to, what is h0 again? h0 is 25. So, the answer is 25 by 5, and that is equal to 5. The ratio is 5. Alright, that is the end of the whole session. Alright then, thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.